Hi everyone, Dr. P here, and in this video we'll take a look at alkynes, namely their nomenclature and properties. Alright, I'm calling this Lecture A because in previous semester I had done this lecture in person, so I'm recording a new lecture video here which you'll want to watch before Lecture B and watch Lecture B before Lecture 1. Anyway, I know it's a little bit confusing, but if you just, check on the course Canvas page, it should tell you everything you need to know. All right, so alkynes. Alkynes contain the carbon-carbon triple bond. So we're continuing on with our hydrocarbons. The general formula for an alkyne with one triple bond is CnH2n minus 2. So each triple bond will be 2 degrees of unsaturation. Now, the CC triple bond is linear. All right, so we would have, carbon or hydrogen, whatever, carbon, triple bond, carbon, carbon, hydrogen, whatever. So that section of 4 carbons is linear. Ways to draw it, you could draw it like I just did here. One thing I would advise not to do is something like that. So we'll say don't do this. When you're just starting out, it is tempting to draw a zigzag like you did with, say, an alkane or an alkene, and then add in your triple bond. But again, this is implying that you don't have a linear geometry when really you do. So instead, you can do something like that, where you just leave a little space, a little gap. Or sometimes a dot is given, like that. Or just go ahead and write out what you need to. All right. So, yeah, again, try to avoid that. Notice one interesting thing is that we often, I wouldn't say often, I'll say usually don't find cyclic alkynes. And then the reason for that is, of course, that if we had a triple bond in a ring, that triple bond wants to be linear, but instead, in this case with a 5-membered ring, we're constraining it to a bond angle of 108 degrees, and that would simply be too strained. So unless we have a really big ring, we're not going to find a triple bond in the ring. All right, a few words about nomenclature. And one nice thing about alkynes is their nomenclature is relatively straightforward. We have a suffix of -ine, Y-N-E, and then of course we start numbering the main chain at the end closest to the alkyne. Or I should say closest to the triple bond. Let me strike that out. Closest to triple bond. So just as an example here, let's say we had the following, and just looking for, I'll just do this, So if we had something like this, we could go ahead and number. We're going to start at the end nearest our alkyne, our triple bond. So I have 1, 2, 3, 4, 5, 6, 7 with a methyl on carbon 6. This then becomes 6-methyl 2-heptine. Hept, of course, for 7. Notice there's no cis or trans, no E or Z. Because it's linear, we don't have to worry about that. So that's kind of nice to know. One common name to know, and really there's just one common name to know when it comes to alkynes, and that is the simplest alkyne, which is also called acetylene. And you may have heard that as a fuel typically used in types of welding, oxyacetylene welding. All right. So that's an introduction to alkynes, drawing them and naming them. Let's take a look now at some properties. And of course, you know, like we've seen with other hydrocarbons, alkynes are going to be fairly nonpolar. Some types of alkynes. So if we have the triple bond not at the end, we would call that internal, an internal alkyne. And if we have the triple bond at the end, at one end or the other, we would call that a terminal alkyne. And this hydrogen here is an acetylenic hydrogen. Okay, because it's like one of the end hydrogens in acetylene. Now, one thing to note, you may remember from chapter 2 when we were talking about acids and bases, acetylenic protons are weakly acidic. For example, if we took a typical alkyne, we would get a dissociation here where our pKa is around 25. So not very strong, weaker than alcohol protons, but because our lone pair is in an sp orbital, these are more acidic than, say, a proton in an alkene or an alkane. So we can use strong bases to make acetylide ions. So if I had R, C, triple bond C, H, and I react that with NaNH2, NaNH2 is sodium, oh, sorry, let me write that correctly here, sodium amide, which is Na plus and then NH2 minus as the amide ion. Okay, that is a very strong base. And so if we react our terminal alkyne with sodium amide, we will get our C triple bond C lone pair negative charge. Na plus NH3 ammonia as our conjugate acid of NH2. And this guy here is a good nucleophile. And we'll see in some of the other lectures that we can use that to do a variety of reactions. All right, well, I think that's enough for this video. I wanted to keep it fairly short. We'll start looking at some ways of making alkynes, as well as some reactions that alkynes can undergo in the next videos. All right, well, in the meantime, stay safe out there. Bye now.